Hello, madam. My name is Cruzan. I'm from class sections D1213. And today, our group will do a presentations video about program executions expressions. So, our group had already designed an in-speech expressions, which is x equals to a minus b multiply c plus d divide e plus f. So our second question is convert an in-speech expressions to post-speech notations step by step. So we have 3 steps to solve these questions. For step 1 is enter parentheses. First, we need to simplify the sub-expressions within parentheses. It means we need to convert the first parenthesis, which is b multiply c, and b multiply c will becomes bc multiplied, and the parenthesis will be removed. And after this, we will get the latest expressions, which is x equals to a minus bc multiplied plus d divide e plus f. After that, we will also convert the second parenthesis, which is d divide e. D divide e will write to de divide, and the parenthesis will also remove, and we will get x equals to a minus bc multiply plus de divide plus f. Step 2. Eliminate remaining brackets and converts. It means we need to handle the substitutions a minus b c multiply. So for this, we need to convert a minus bc multiply to abc multiply minus, and the bracket will be removed, and after this we will get x equals to abc multiply minus plus de divide plus f. After that, we will also convert de divide plus f. So de divide plus f will like to de divide f plus, and the bracket will also be removed. And after this, we will get the latest expressions, which is x equals to abc multiply minus plus de divide f plus. So for final steps is we need to convert plus de divide f plus, and this plus de divide f plus will becomes de divide f plus plus. And after that, we will get the final answers, which is x equals to abc multiply minus de divide f plus plus.
Hi, madam. My name is Liang from class D12D13. I will present the part of stack diagram. First, let me see the expression first, which is x equal to a minus b multiply c plus d divide e plus f. For my method to do the stack diagram, I will look for the zero address. First is the push A. We write the A in the diagram and next is push B, write the B, push C, write C, and then for the multiply, look at the top two, which is B and the C, and then multiply it. It will become the B multiply C. Next is subtract. We also look at the top two, which is A and the B multiply C, and then subtract it. It will become A minus B multiply C. And next is push D, write the D, and then push E, write E, and then it's divide. We look at the top two, which is D and E, and then we divide it. It will become D divide E. And then it's push F, and then it's add. Look at the top two, which is D divide E and F, and then we add it. It will become D divide E plus F. And next is add also. Look at the top two, which is A minus B multiply C, D divide E plus F. And then we combine it, add it. It will become A minus B plus B multiply C at D divide E at F. And next, and the last is the form S. It's meant to add the X equal in front. So the finally answer will become X equal to A minus B multiply C plus D divide E and the F. It's all for my part. Thank you.
Now let's talk about the one address machine instruction. So now here we have our questions. So first step, we're gonna look at our postfix notation, which is this. So the first step we're going to do is the B multiplied by C. So first step is we're gonna load B to the accumulator, and it will be multiplied by C, and we store it to the register Y. So we can load A to the accumulator and subtract it by the Y, which is the value we just save it here. Now we're gonna store the answer to register Z, so we can load D to the accumulator and divide it by E. Then we'll add F and add Z, so it becomes the final answer here. And we store it at X because X is what we're gonna show at the end. Like this one. Now let's move on to two address machine instruction. So in two address machine instruction, is not like one address machine instruction. We use move to represent load. So the first step, we want to load B to the register 1. We use move register 1 B. Now the B already in the register 1, we multiply it by C. So we can still in the register 1 and multiply it by C. Now we're gonna load A to the register 2, and the register 2 we are going to subtract that by register 1, which is the B times C. And now we're going to move X D, which means we load D to the register X, which is also the which is also the we want to show it as the final answer, which is X here. So we've moved X D. Now we're gonna divide X by E. Then we will add X with F. So this is D divided by E plus F. And now we're gonna add X with the register 2, which is combine the whole thing together and get a final answer.
Hi, my name is Saira binti Surahman. Today I will explain how to do the tree address machine instruction. Expression is X equals to A subtract to B multiply C plus D divided by E plus F. So the first instruction here is divide R1, D and E. So D divided by E and start into register R1. Next instruction is add R1 R1F. So we copy back the D divided by E and plus F. Then store it into register R1. Next is multiply R2BC. So B multiply C and store into register R2. Next is sub R2 AR2. So A subtract to R2 is B multiply C. And store into register R2. The last instruction is add X R2 R1. So we copy back the expression and store into register X. So this is the tree address machine instruction. That's all. Thank you.